So, good morning, everybody. I guess we can start. Still people walking in, but it's okay. Yeah, I would like to welcome you to the next presentation about high availability or high performance, or also how I call it, how to sleep without the server crash fear. Maybe short introduction of myself. I'm head technology of a Drupal shop in Switzerland, and we started building servers for our customers. And of course, if you have servers for your customers and you don't want them to die or whatever, to crash during the night, so you couldn't really sleep. So after I was standing up the second or the third time at 2 o'clock in the morning, I said, okay, let's fix this. I would like to have servers which can die, but it shouldn't lead into the website not working anymore. So yeah, I would like to tell you what we have done, what we're doing today, what we have learned, what works, what doesn't work. But first, maybe a short introduction. What is high availability? What is high performance? High availability means you basically have no single point of failure. That means you have a system where something can break and the whole thing as a structure still works. So you can reach this in adding redundancy to your whole system, basically making everything double. What means high performance? Of course, response times, fast websites, but it also means caching, intelligent caching, caching of full HTML things or single data, serialized, as we heard before, CMI. Instead of actually going to the files and loading them, which uses disk I/O, we use some kind of caching mechanisms where we can save actual PHP data. And of course, high performance also means that you easily can scale depending what you need. Because maybe you have a website which doesn't need super speed all the time. We built, for example, a website once for the German television, and they showed the URL during the prime time at Monday evening, and we had easily 2,000 hits per second, but then 2 hours later and the whole week, we had maybe 1 hit per minute. So we had to find a system where we can say, okay, we need a lot of servers on Monday, and basically one single server is way enough during the whole week. So you want to build a system which is easily scalable to a certain point. So means you can adding easy and fast more servers without reconfiguration a lot of things, or maybe fully automated. So what we build is a scalable and redundancy server system. What everybody knows is probably this. We have users on the top, and we have an Apache and a MySQL, which is basically our server. So that's the minimum things you need to run a website. What we've built is this. But let's go back. Let's start from the beginning how we got there, because you don't stand up in the morning and have the idea of this. So you first start, basically what happened, the Apache dies in the night and the website is gone. So you think, let's add 2 web servers. If one dies, the other one is still there, no problem at all. What we use for Webserver is Apache. Apache is probably everybody knows. For performance-wise, one thing which everybody suggests is using APC. What is APC? APC is a module actually for PHP, and it pre-compiles the PHP files. So instead of loading the file every time the website is actually created fully from the file system, it pre-compiles it and does already some optimizations on the files. Which means then when actually the second time the PHP file is loaded or queried, it's faster in loading and executing. And it also keeps the files in the memory. One important thing here, the problem is that APC ships defaultly with 32 megabytes of file cache. Now what happens? Your normal Drupal site, and if you run 2 Drupal sites on one Apache server, it fills this easily up. So basically it has more files to cache as actually APC has available in the memory. So what happens? During a Drupal site load, a normal bootstrap, whatever, it fills up the memory. And then at a certain point, the memory is full, but it adds new files to this memory. So it removes the opera ports. So basically, at each request to the server, it flushes the memory and refills it, which makes the whole site slower. So one important thing there, if you enable APC, you have to make the memory, which APC is allowed to use, way bigger. We use around 400 megabytes. That it is enough space for APC to actually cache all these things. If you just enable APC on a Drupal site, which has multiple sites running, it will make the whole site slower. So one important thing, but overall APC gains a lot of speed, and it's only like a turn on, configure one line of code, and that's it. And it makes your Drupal site a lot faster. Beside of Apache, we actually have Nginx. Nginx started as a lightweight web server, and it still is. But beside of actually doing web server, you can also use it as a reverse proxy or as a load balancer. Nginx can be faster. It's not overall that Nginx is faster than Apache. It's, let's say, a bit intelligent build than Apache, which can do everything. And Nginx is more like specifically to things, but you need more knowledge how to use Nginx, because all the things which you find right now with PHP and Drupal, and even Drupal ships with an own htaccess file, which is for Apache. So you have to build your own configuration files for Nginx and other things. So, which means if you want to use Nginx, it's not only like turning on and it works, you have to read a bit, but it can be faster if you really want to dig in and find how it works, how to configure Nginx. So we have two web servers. Now the question is, okay, where do we put the MySQL? Because if we put the MySQL on the first server, let's say on the left server, and we have the right server, which queries the database on the left server, if the left server dies, your website still doesn't work, because the Apache alone cannot serve a Drupal site. So let's go back again. We have our own server. The first thing we do, we basically extract or dedicate the MySQL. We have two servers, an Apache and the MySQL. And now we easily can add a second Apache server. They both now access the MySQL, query them whatever they need. And so if one of the Apache server dies, the other one still can access the MySQL. No problem at all. Basically everything works. The question is now, as you see on top, from where the users know to which Apache servers they actually should go to. You have two servers, but the users will just query a single domain, like whatever, Drupal.org. So to which server should it go? What you can do in the DNS, you can say two IP addresses, which is called round-robin DNS. Basically, instead of telling Drupal.org is 1.1.1.1, you say beside of 1.1.1.1, it's 2.2.2.2. This works pretty good, and uses automatically round-robin between these servers, because your client will say, well, I've chosen once this, then this, and this, and this. The problem is, if one of them dies, and actually nothing replies anymore to 1.1.1.1, 50% of your users will not see the website anymore. Or maybe they see it once not, they see it not, they see it, etc. So DNS round-robin is not really a solution for this. It can work, but it's not. So the easy thing is to put a load balancer in front of it. So basically you say, you have a load balancer which knows which servers are behind. If server 1 on the left side dies, the load balancer will automatically tell all the users, please go to server 2. If both are there, he basically puts them between. So a load balancer does nothing else than actually passes through the requests. He gets a request from the user, he checks which server is available, and he sends into this, and the traffic goes back to the load balancer. So basically, it's a man in the middle, which the user doesn't even realize that there was a load balancer. Some load balancer are fully passive, so you don't see anything at all. Some of them add a specific header for debugging. that you know through which load balancer it went and all the stuff. But yeah, basically. So we have our load balancer, and it load balanced between these two Apache servers. But still, we have one single load balancer. So you still need a possibility to say, okay, if this load balancer dies, you need another one. So basically what you use is a second load balancer. So why do we have two load balancers and two Apaches? What we want to have easily possibility to add additional Apache servers. Because these are actually the hard workers. This is where the PHP is running, this is where the whole calculation is done and the whole website. The load balancer is a pretty easy thing. He just have to pass through requests. So we can easily add additionally Apaches without adding additional load balancers. Because one load balancer can maybe handle 100 Apache servers. So that's how we get the scalability. We have one single thing which only does the requests, and then we have the Apache. But important is to know that each load balancer knows of both Apache servers. Because maybe the requests go in both load balancer in, but the left Apache servers maybe died, so they both have tend to pass through the request to the right server. So we have a system, it works until the person or a user of your website first uploads a file. Drupal saves the files in a directory on the server. So this means if a user is on server left and uploads a file, and then another user comes and he accesses server right and was to read the file, their file doesn't exist. So that happens like if you press F5, sometimes the file is there, sometimes not. So we have to find a solution for our files. We also have to extend the file, extract the files somewhere else. The easy thing you come up if you search for this, NFS. NFS is a pretty old file system via the network file system. This means you just bind a specific folder on the NFS servers on both Apache. So this means if a file is uploaded to the Apache server, to the left one, it's actually saved on the NFS server. So if the right Apache server wants to access it, he accesses the same folder on the NFS server, and he can load it. No problem at all. But, well, we have only one NFS server. If the NFS server dies, all our Apache servers have no files anymore. So we have to find a solution there. The problem is NFS in itself is not able to do redundancy. It's just built to having one single server. You can build with some Heartbeat and other technologies. You could build something where the NFS is redundant, but out of its own, it's not possible. So we searched for a solution for this, and we found GlusterFS. GlusterFS is basically targets especially the problems of NFS, which is not redundant. So GlusterFS is a distributed file system. You basically set up GlusterFS on 2, 3, 7, 300, 10,000 servers, and they automatically sync the files between. You can say that's like my server and that's my client, that you still have like one single point where all the files are saved, but the other ones automatically update. So basically you have multiple servers and clients which just sync their files between each other. And the cool thing is it's auto-healing. So basically if one server dies and is away for 10 weeks, and then he comes back into the Gluster server cluster, he realizes, oh, I have old files, and downloads the other files from the other server, so he tries to heal itself. What can happen is a split brain. That means if multiple servers, let's say you have 10 GlusterFS servers, and 5 basically split between. They have no connections, but each of these 5, they still know from each other. And then at some point, they go all together to 10 again. It could happen that a file has changed on one side and another file and the same file on the other side. So the GlusterFS doesn't really know anymore which file is now, should I use the newer one because it has no merging technologies as Git or whatever. So a split brain still can happen because you have no single point where all the files exist anymore. But it actually, I mean, we tried a lot of things, and GlusterFS is pretty good to tell, okay, which file is probably the most important one. And you can also tell GlusterFS what he should do if he realizes there is a split brain. He can either inform you via mail, or you can tell him, like, this server is the most important one, or whatever. So there are technologies how to work with a split brain. The problem is a bit, it's not so fast. Because every file which is requested still has to be checked if it's actually new or not, or whatever. It just needs a lot of checks via the it needs a lot of network traffic, and it just needs checks if there is a new file or whatever. The good thing is, in Drupal, a file is actually never replaced. It's just added new. So if you upload a file multiple times with the same file name in a Drupal site, it's just added with a suffix. So this means you never really have changing files in your sites folder, or in your files folder, which helps GlusterFS to actually never check if a file has changed or not. So one thing we tried at the beginning, so basically what we added, a second GlusterFS server means if one dies, you have another one, etc. Same reason as before. So we have two GlusterFS server, and our Apache act as clients, and they request GlusterFS. And if one of the server dies, there's still another one, and they updated each other. One thing we tried is, let's think about deployment. Imagine you have 10 servers, and you have to update at the same time the PHP files. Like, you updated your own custom module and you want to deploy this to all servers. Wouldn't it be cool if actually the Drupal site is also running in GlusterFS? So instead of just pointing the site's default file sorter or a folder to a GlusterFS, you basically point the whole Drupal site to GlusterFS, and it works. So basically you just make like a git pull on one of the GlusterFS server, and all the clients instantly realize there is a new PHP file, they update it, and the next time it's requested the new site. So perfect deployment. The problem is it's about 10 times slower than actually running the files directly from Apache, because what happens, PHP checks, or APC if you have enabled it, checks if there is a new PHP file every time a page request goes. GlusterFS says, well, let's check first with the other servers, maybe there is a change. So you end up in a lot of network traffic, and it doesn't really help you. So GlusterFS is really only for the files which are uploaded by the users, so your site's default files folder, and all other PHP, configuration, settings, PHP, whatever, should stay on these single Apache servers, and you better use a deployment script which automatically goes to each server and pulls or whatever you need for the deployment on all these Apache servers. So we have a system. We have two load balancers. They load balance between the two Apache servers. We can easily add a new Apache server, and the files are extracted into a GlusterFS servers. They are also double. Now, we still have one single piece there. That's the red one, the MySQL. The MySQL still is his own. If the MySQL dies, the whole lovely system on top still would not work, because Drupal needs our database. So how are we doing MySQL fallback? What happens if the MySQL dies? The thing you basically need for this is MySQL master and slave. So basically you say, I have a MySQL master. That's my master, and that's where the data is actually saved. That's where the actual data is. So you use it for write. Every write command goes to the master, and then the slave are only used for read things. And the master and the slave automatically replicate between this. And this basically works that every command which is sent to the master, after the master executed it, he sends it to the slave, or multiple slaves. That's called a MySQL bin lock. So basically it saves every command which happens in the right order. He saves on the master and sends to the slaves. So let's imagine I go and change my username. So there's an update, which is also a write command. It sent, PHP realizes automatically, oh, that's a write command. I should send this to the master. So PHP opens two connections at the same time, one for the slave and one for the master. And if there is a write command, it sends to the master. It's happened on the master, and the master with the slave itself replicate. So the update is sent to the slaves, and the next time I actually read my own username, when I refresh the page or whatever, Drupal realizes, oh, that's only a read, so I go to the slave. With this, I basically fix two things at the same time. First, if one of them dies, I still can read. But it also makes the whole site faster. Because in a normal Drupal site, around 95% is reading and not writing. Depends on your Drupal site, but that's the usual thing. You read, you only display information. So you can use a slave and a master to make it faster, because writing goes to one and slave to another and reading to another, or you can add multiple slaves, which then reduce the speed, because all the joins and stuff need CPU power, and you can easily add this to multiple servers. But we still have the problem of what happens if the master dies. Then I can only read anymore, I cannot write. So basically we do hot spare. That means one of the slaves is decided or is defined as a spare server. So if the master dies, a slave becomes a master. And the cool thing is he has all the information. The table and the whole database is exactly the same. You just at this one specific point you have to tell the Drupal, okay, now you use this one as a master and this one as a slave. If you have multiple slaves, they also have to realize that there is a master, but that's basically all built in MySQL. So we extend our MySQL master with two MySQL slaves, and one of them is a hot spare. And if one of the slaves die, Drupal actually doesn't care. He realizes, oh, one of my slaves is not there, so I still go to the master. If the master dies, you have to do specific things to tell now Drupal, this is now the MySQL slave. At the end, that's actually not so hard. You can, because the definition between MySQL master and slave is in settings PHP, so you can tell, like, you can run a cron job or whatever you would like to do, depends on your system. If the MySQL master does not exist anymore, just use the MySQL slave. In our specific system, the IP address between the MySQL master and the MySQL slave are shared. So there is an external system which is called Heartbeat. When MySQL master dies, the MySQL slave gets the IP address of the MySQL master, so Drupal doesn't even realize there was a change of servers there. But that's a specific thing. That's how basically master and slave replication works. So with this, we have a full redundant system. If anything of the server dies, so is it an Apache, is it a local answer, is it a GlusterFS, is it a MySQL master, whatever, the system auto heals and you can sleep. Maybe at 2 o'clock in the morning when one of the Apache dies, you maybe wake up because you get whatever, a Twitter message that one of the server dies, but there are still 2 others. So you fix it in the morning at 8 o'clock and not at 2 o'clock. And that's basically what we want to do. We want to sleep and not get up at 2 o'clock in the morning. But it's not the highest performance system. If you get a lot of traffic, like the one we did for the television at the German television, if you have 2,000 access at the same time, you still need things to make the site faster. So basically what I talked about now was all the high availability things. Of course, you get performance at the same time, but there are a lot of things what you can do on server side to make your whole Drupal site faster. One of them is Memcache. what Memcache is doing, basically, it replaces the cache tables in your Drupal. They are still there, but they're empty. And he saves the whole thing in a key value store in the memory. So it's the same thing as in the Drupal cache tables. You have a key and a value. But instead of actually going to a database all the time, which is just like load me this key, like load me this variable or whatever, there are faster technologies to do this. We ship Drupal with a MySQL cache per default because we don't want that every site in the whole world which wants to run Drupal has to install Memcache. But if you want to have a fast site, there are a lot of possibilities to do this. The good thing is about Memcache, it's faster, or now faster, but it's only saved in memory. So if your Memcache dies and restarts, everything is gone. Where in the database, it doesn't matter. If you restart the MySQL, the whole cache is still there. And there are possibilities where you can put like locking or sessions also to the Memcache. So beside of just the normal cache tables, you can make the whole session, like if you have a website which has a lot of sessions at the same time and people are all logged in, and Drupal has to query all the time the session table, you can put this in Memcache. Or the locking, which is implemented in Drupal when you have to lock some specific things, you can put this in Memcache. But if the Memcache dies, it's gone. So all your 10,000 people which are logged in and the Memcache is away, they're locked out. Because the whole information was in memory. If Memcache is away, the memory is gone. There are possibilities to fix this. There are new implementation of Memcache which do like replications at multiple servers. But at the end, this adds then another another layer of complexity, and it makes the whole site slower again. So, yeah. The good thing is about Memcache, it's its own server, because APC itself has also a memory storage. But if we check back again, if we have our own memory safe in the Apache, on each Apache, and if we have 10 Apaches, they all generate their own cache, which we don't really want. We want to share, we want to distribute and share the cache. So you build a Memcache, which basically extracts the cache table from the MySQL, and now the Apache can access the Memcache. We still have to think, if the Memcache dies, then what happens? Basically, your site will be slow. It isn't that it doesn't work anymore, it's just slower, and the Memcache module can fall back to the MySQL master, but there is a possibility to add 2 Memcaches. So let's do this. We just have 2 Memcache servers. If one of them dies, the data is gone, but there is still the so the cache is just rebuilt on the single server, which is not so super bad. So we have a fast site. We save some stuff at the cache tables with Memcache. If the users are logged in, it's pretty fast. But if we have a site like whatever, let's think Drupal.org, for example, has a lot of hits. Just random people searching for Drupal and go to the start page of Drupal.org without being logged in. This page looks the same for every single person. There is no GeoIP or whatever reroute. If I go there and I go and another person goes again, the page looks exactly the same. But what happens? The whole call goes through the load balancer, goes to the Apache, Drupal bootstraps, the MySQL is loaded, he checks if there is a file, loads the file, do I have to make a Memcache, all the things. So every server is involved for each single hit, and at the end, the page which is actually generated looks exactly the same as before. So if I press F5 on Drupal.org, it doesn't look different. So Varnish to help. What Varnish does, it's a reverse proxy. So Varnish, you put in front of your Apache server, and Apache caches the full HTML pages. So the first time, let's say Varnish just started up. I request the website, drupal.org, and the whole DNS stuff is done that it goes through the Varnish. Varnish says, I never have heard of Drupal.org, but I have my backend, which are the Apache servers, I give it to them. So he gives them to the Apache servers, the Apache generates the whole thing, and it comes back to the Varnish. And the Varnish says, okay, thank you, I saved this for now. And the Apache can define the Varnish for how long it should be saved. So the next time in this cache frame, when another user is coming to the Varnish and says, I want to request Drupal.org, Varnish says, hey, I have this already for you, so I give it to you directly. And PHP, Apache, Drupal, Memcache, MySQL, nothing is invoked at all. They don't even realize there is a hit to my site. So I define a cache timeout like, let's say, an hour, because my site probably updates every hour. And every request, the first request is done, and every other request during this hour is just handled by Varnish, which makes the whole thing really, really, really fast, because Varnish is optimized to the maximum. It's actually built from one of the core maintainers of FreeBSD. So it is faster on FreeBSD as Linux, but you probably will never find out. But it's really fast built because it does only reverse proxying. It saves the whole thing in memory, so which means no disk I/O, etc. So it's really fast. The problem is Varnish hates cookies and sessions, because Varnish has to find out if the site which he should show, if it looks different or not. We see later an example for this. So what Varnish says, if there is a cookie, which means there is a session running, Varnish does not cache the page at all. If you request Varnish with a cookie, it says, oh, I will not, even if I have a cached page, I will not show this to you, and it just passes this back to the Apache. So basically, if you are running on a cookie or on a session, Varnish doesn't help you at all. What you can do, you can say like, the image looks the same all the time. So you can already say, okay, even there is a cookie, but the request is only for an image, I still cache the whole thing. So it already makes your site faster, because all images, all CSS files, all JavaScript files are not requested all the time to the Apache. One important thing about Varnish, he doesn't like SSL at all. So if you have a website which needs SSL, you can, if you pass something to Varnish with SSL, he just passes it back to the Apache, because Varnish itself has no possibility to actually extract SSL. So he doesn't even know what to show, because there's only an SSL request, so you don't know which URL is requested and whatever. But what you can do, in front of Varnish, you can make an SSL terminator. So basically each request to SSL is first terminated in front of Varnish, and this terminator translates SSL to non-SSL, and then Varnish basically doesn't even know that there was an SSL request, and then it works again. But it just needs an additional thing in front of Varnish. So Varnish with Drupal. The problem is Drupal 6, which is a bit old but still used, creates a session for every single page request. So if you have a site and you just, doesn't even generate something special for the user, it just creates a session. Maybe for later use, it just created. There's a thing which is called PressFlow, which basically introduces lazy session handling, which is also built in Drupal 7 and 8. So the PressFlow says, when I only show you a website, I don't need a session yet. So you haven't yet created a form, you submitted the form or whatever. So he doesn't create a session until you actually really use it. This means until you log you in, until you poll, like you use the poll module or whatever. So it helps Varnish to not create cookies and sessions for normal sites. And PressFlow also introduces a specific header which tells the Varnish for how long this page should be cached. because Drupal knows about the site. Drupal knows that the front page maybe changes every hour, and Varnish doesn't know. Varnish is pretty stupid in this. So Drupal has to tell the Varnish how fast or how long it should cache the whole site, and that's done by PressFlow. As I said, Drupal 7 and 8 is basically in core, so we just have to enable it, and that's done. So that's how our system looks, what we have running right now. So in front, so the users are accessing a redundant load balancer, which is hardware redundant. So basically we have a redundant system, which is also an SSL terminator. Then there is a Varnish, and the Varnish makes, again, a load balancing between the Apache servers. So if one of the Apache server dies, the Varnish still knows about this. The Memcache are extracted, we have a MySQL master, and we have a MySQL slave. And basically, if we get a lot of traffic, the only thing we have to add are these single Apache boxes, nothing else. And we only have to tell the Varnish, both Varnish servers, hey, there is a new Apache server now, or there are 10 new. And basically how the whole thing happens is Varnish knows already of all possible 10 Apache servers, but we just shut down 8 of them. So if you know that you get a lot of traffic, you just start additional Apache servers. Varnish realizes, oh, I have 2 new servers, and that's done. And the whole site is, or you can make faster traffic. So that's basically what we have running. If anything dies, I can still sleep at 2 o'clock in the morning, which is perfect. But of course, there's new things happen. One of them is called ESI, Edge Site Server Includes or Edge Site Includes. So here's a website we have built for one of a government organization in Switzerland. That's logged out. That's how the site looks like if you're logged out. And that's how the site looks if you're logged in. Have you seen the difference? Let's go back. So you see, it's only a small thing on the top. Basically, my name is shown. How cool. But all the other site is still the same as a normal user would see it. And that's where ESI comes in. So basically, you tell the Varnish if the website is called, instead of actually passing in the Michael Schmid, my username, I put in an ESI. That's an ESI. So instead of actually rendering, which is a block, I put instead of the HTML for the block, I put in ESI include source www.osec.ch/userblock. And what happens with this? Varnish will now cache the whole site for 1 hour. That's the TTL 1 hour. And the single part which actually changes is passed all the time to the Drupal. So this means Drupal doesn't have to load every node, every picture, every menu, everything at all. He just has to know from the session or from the cookie what username you are. And that's way faster than loading the whole thing. So what ESI is doing, it caches the whole page for me really fast, and it only loads small single parts of my Drupal site, specifically personalized to the user, to the current cookie, which is way faster. ESI works with Varnish, Schmid, and Nginx. So basically, you can use Nginx like as a replacement for Varnish. So there is a Drupal module for it. And it works for blocks, panel panes, and context module. So you can say, like this block, imagine the one which shows my own name, on the top is like never cached. So this should please be loaded all the time. I can also say cache it for like an hour. So I can cache the whole website basically for a week, and the small user thing on the top is cached for an hour. So Varnish will only load every 1 hour if maybe my username changed, but the whole site, all images are still cached for 1 week. The problem with this, it's not something you like just enable. You have to really know how your website works. If you change a layout thing on your site, you have to think about this, so it needs a lot of time to find out what actually works. But with this, you basically can build websites which are big, and only like some small parts are special, and all other things are still cached, which is the end what we want to do. We want to serve as fast as possible sites, but still personalize them. But if you really think, the personalized parts are really small on a whole site. Like on Drupal.org, the start page looks the same, and it just shows me the small name on the top, which is my known username. So that was a bit about the future. Yeah, questions for what we have today or the future of high performance and high availability? Taste.
Hi. A question about the master and slave MySQL.
Yes.
When I was playing with this, I realized that Drupal core basically uses master all the time. Is that true? And you can configure views to use slave servers, but Drupal core will not.
It depends which Drupal version you're using.
So if you use PressFlow or something like this, it will...
Yeah, the problem is, with PressFlow, I assume you use Drupal 6.
Drupal 7.
Drupal 7 with PressFlow.
I'm not using PressFlow,
Okay.
I was using the...
Yeah, the thing is, Drupal core will use the slave only when he actually knows that it is a select. So basically it uses for DB select things. If you make a DB query, he will assume, well, you could make a write comment or an update. So it's only used when when actually the DB select function is used. But it should use the slave, or at least it works in our case. And you can really see a performance bump or speed bump at if it uses the slave. Maybe it was wrong configured, whatever.
Maybe.
Yeah, maybe.
But you just have to configure this database array and everything should work.
Yes, yes. I can show you an example later how we configure it and it works.
I'd like to see it. Another question with Varnish. I have a strange case where sometimes it happens that the content editor, when, for example, edits a node,
Yes.
and saves that node, it gets displayed the old version of a node
Yes.
when the form reloads.
Yes.
And it looks like the Varnish was returning the cached version of a form, which is a bit strange. And I
Yes.
think that this happened after we started to play with grace mode. So do you have maybe some
So you're
experience
you're using grace mode on Varnish.
Yeah.
Yeah.
I mean, I was not configuring it. It's
Okay.
our system administrator, so I'm not completely aware of all the circumstances around here, but I think it started to happen because now they blame me that Drupal is doing this, so that's why I'm asking.
Okay,
this.
there is one important thing, which is here. Not sure if you can see it. This. Basically, what you can tell Varnish how he should find out if the site is different or not. And defaultly, Varnish uses the URL, the accept encoding, so it depends on the language, and the vary header. And the vary header can tell a reverse proxy if you should use the cookie or not. If you set this, and if you read the top thing here, it looks pretty interesting at the beginning. It says, hey, it makes your website faster. But it basically tells the Varnish to not use the cookie as a specification if it changed or not. So even if you're logged in, it will still show you cached sites. So that's maybe one thing. If this is enabled, that's the case, yes. Because Varnish will say, well, even you're logged in, I just show you old stuff.
Okay, so you have to disable this on Varnish.
No,
Oh.
just leave it like this.
Okay, just comment it.
Don't say omit vary cookie true. You can set it to false, but that's the default.
Yeah.
But not enabling this can help this. With grace mode, it's hard to tell. It shouldn't happen actually. But I've seen people just enabling this, reading through the settings, PHP saying, hey, that's cool, I enabled this, and then it happened.
Okay.
One
I'll check.
important thing also is what we had some couple of times is that browsers start to do caching pretty crazy. Like Chrome is pretty good in like preloading things and stuff. Now, what happens that the Chrome specifically interprets the same headers. So basically, the headers which are sent to Varnish, Varnish just continues to sending to the browser. So the browser sees, oh, I should cache this site for 900 milliseconds. So if you're locked out, the browser gets a website which says cache this for 900 milliseconds. Now you log in and you redirect him back to the front page. The browser says still, oh, I have this cached. So I show it to you again. So basically the user is on the page, logs in, presses submit, and comes back to the start page logged out. Then he clicks to some, logged or not logged in. Then he clicks to any link and he's logged in. So what we did there is basically configure Varnish to not tell the browser at all if you should cache this page or not. The problem is sometimes you want this. So it really depends. But if he was already logged in, this never happened for us. So I think that's probably the case.
Okay, I'll check it. Thanks.
To use the Edge site includes, I have to use a module or I have to display it in my theme or something?
So what do you mean? What do you have to do to use the ASI?
Yes, it's in Drupal.
Yeah. Well, if you install the module, you can say per block if there should be an ESI or not. So basically it handles everything for you. So but as I said, it really depends on the use case, because sometimes specific stuff is loaded in the whole page. It's not a specific block. But if you use a block system or a context or panel panes, it basically works. I have to tell we use it for productions. We don't use it right now for production sites. Because it just needs a lot of time. If you have a specific case where it helps you, it can be awesome. But most of the time, you like, it also depends on your site. Like 90 to 95% of your visitors are logged out and not logged in, unless you're called Facebook. Then it's a bit a different story. And if you say, okay, let's make the site really, really, really fast for anonymous users, and for logged in users, I just use Memcache or whatever that the whole site is fast.
Okay.
Hi, sorry if you've already said this, but what load balancer do you use, and also how do you handle failover between the two load balancers?
I cannot tell what we actually use, because it's the load balancer is handled by our hoster. We use a level ISO level 2, so basically he doesn't even know about he doesn't even know about HTTP. So it's a hardware load balancer with 2 power supplies and everything. So he's built for redundancy, and you can only define, okay, do this. If you're really interested, I could find out. But we use Heartbeat for the MySQL to find out which one. But I have to say, I'm not the super perfect person to talk with this, because that's like really hardware configuring it, and that's done by our hoster.
I had just one other question, which was about file system stuff. Out of interest, why GlusterFS over Heartbeat plus NFS? Any particular reason why you went with GlusterFS over the NFS plus Heartbeat approach?
Well, the thing is, it's just history. Basically, we had the whole site running, and then the NFS died. And then you search for a possibility. And at this time, the whole thing was hosted in Amazon Cloud. And at Amazon Cloud, or EC2, you have no possibilities to use Heartbeat, because Heartbeats needs to change IP addresses of servers, and you cannot do this in Amazon. So GlusterFS provided us the possibility to to basically fix the NFS issue without actually having access to the servers. Right now, we already moved everything back to dedicated servers. So I guess we probably go back to NFS and Heartbeat, which is faster than GlusterFS.
Okay, thanks.
Okay, good. So have fun, make fast websites. Or you have to say. There's one question.
We've been using Varnish as well in our projects for some time now, and I was wondering if you're using VCL as well, the Varnish language, so that you can define which, if certain users may even pass through the cache entirely and stuff like that.
So the VCL is just a Varnish configuration file.
But you can program in it as well. You can say then, if you have URLs like that and you have cookie set, that's cookie and stuff like that.
Yeah. Well, I mean, we have enough time. Let me show it to you. Yeah, so probably easier here. Yeah, so we use a lot of quite some different things. So we do stuff that specific things are passed all the time, like Ajax stuff. We had quite some issues in the past, but one important thing is this. So, which means every file which has PNG, HTML, whatever, which are assets, we unset the cookie for finding out if it changed or not. Which means then he jumps back to a 2-week thing, and this makes your page already faster without even enabling press flow or whatever. Or if you go further with the Varnish module, that's maybe one thing. There is a Varnish module for Drupal, which can tell if you change the start page, it will tell Varnish. Even if you will cache this site or this page for 1 hour longer, purge it now. So and for this you basically just put the Varnish in front of you and all the files are loaded really fast. Yeah, and then you just have other things. That's maybe this one here. The problem is if you use Google Analytics creates cookies, and you'd have to tell the Varnish that cookies are not, Google Analytics cookies should not be used as the normal cookie determination if it's logged in or not. So basically we say, okay, unset all cookies except everything which starts with ses, which is the default session cookie, or with no cache. So yeah, but there is a really good blog post of Lullabot, which they show their default VCL, and that's 80% of it you find also there. So if you search for Lullabot Varnish configuration or something, that's what you find.
The last thing I would just like to mention is that we have a module on Drupal.org called Steroids, which incorporates a lot of stuff that you said concerning the Varnish and purging, the purging of node data. So if you update a node, that purge is sent to Varnish to remove it from the cache. Yeah, it is in dev, but we're using it on 2 or 3 sites now since about 6 months, I think. So you can have a look at that. It has a lot of stuff that you would really need, according to us, to properly use Varnish and when publishing content, to purge the front page and the views and stuff like that.
Okay.
And it also has a configuration page which allows you to tell which URLs are to be treated as easy and stuff like that.
Okay, cool.
So,
awesome. Okay, good. So, have a nice day.